The next AI bottleneck may not be chips, it may be a transformer, a substation, a grid connection, permission to draw a massive electrical load. That sounds strange, because the AI story has been told as a chip race. Who has the GPUs? Who has the best model? Who can spend the most? Who can build the biggest data center? But here is the problem. A company can announce a $10 billion AI data center. It can buy the land. It can raise the money. It can order the chips. It can sign the cloud customers, and still create zero usable compute. Why? Because planned compute is not operating compute. A chip order is not AI capacity. A construction site is not AI capacity. An announcement is not AI capacity. AI capacity begins only when the hardware is powered, connected, cooled, permitted, and actually running. That is the gap the headlines usually miss, and that gap is where the value may be shifting. By the end of this video, you will understand three things. 1. Why the AI infrastructure race is quietly moving from a chip race into a power race. 2. Who gains bargaining power when electricity becomes the gatekeeper. And 3. The signals to watch over the next 6 to 18 months before the headlines catch up. This is not a stock prediction. It is not a panic story. And it is not an argument that chips no longer matter. It is a business question. When the bottleneck shifts, who gains control and who gets squeezed? Let's start with the framework. There are two kinds of compute in the AI economy: planned compute and operating compute. Planned compute is what a company says it will build. Operating compute is what can actually run. They are not the same thing. Planned compute lives in press releases. Operating compute lives in substations, transformers, cables, cooling systems, utility approvals, and power contracts. Planned compute can move at the speed of capital. Operating compute moves at the speed of physical infrastructure. That difference matters, because the first phase of the AI boom was about Gate 1. Who can get the chips? That was the obvious bottleneck. If you could not get advanced chips, you could not train frontier models, serve huge customers, or compete at the top of the AI stack. But the AI economy is now moving into Gate 2. Who can make those chips actually run? That is a different game, and it changes the map of power, because money can move faster than infrastructure. A model demo can appear overnight. A benchmark can go viral in a day. A product launch can dominate the news cycle in a week. But a grid connection does not move at software speed. A substation does not appear because a company announced AI infrastructure. A transformer does not arrive because capital spending increased. A utility queue does not disappear because investors are excited. This is where the AI story becomes physical. A data center is not just a building full of servers, it is a continuous electrical load. It needs stable power, backup power, cooling, transformers, switchgear, cables, substations, utility coordination, local approval. And all of that has to work before planned capacity becomes usable compute. But when you see a headline that says a company is building a massive AI data center, the better question is not only how big is it, the better question is, can it get power? Can it connect? Can it operate? Can it do that on schedule? And can it do that at a cost that still makes business sense? That is the conversion problem. The market sees an announcement. Investors see capital expenditure. Customers hear about future capacity, but operators need something much more basic. They need power. And this is why the business question is changing. The first question was, who can buy the chips? The next question is, who can convert chips, land, money, and electricity into operating capacity? That is much harder, because it is not just a software problem, it is an energy problem, a land problem, an equipment problem, a permitting problem, and a timing problem. Now, before we go further, here is the key distinction. I am not saying chips do not matter. I am saying a chip that cannot be powered is not capacity. If that changes how you read AI data center headlines, hit like so more people can find this framework. Now let's talk about who gains from this shift, because if electricity becomes one of the gates to AI growth, the winners are not only AI labs, they are not only chip companies, they are not only cloud platforms. The players closest to power access start gaining importance. Utilities gain importance. Grid operators gain importance. Power equipment suppliers gain importance. Owners of power-ready land gain importance. Data center developers with secured interconnection gain importance. Infrastructure operators that understand power procurement gain importance. Why? Because AI infrastructure is no longer only about who can spend the most. It is about who can convert spending into usable capacity. That is a different business. Now look at who gets squeezed. AI startups without infrastructure control may get squeezed. Cloud customers without bargaining power may get squeezed. Late data center developers may get squeezed. Regions with land but weak grid readiness may get squeezed. Enterprise customers may eventually face higher costs, stricter contracts, or tighter usage economics. And behind all of that is one harder question. Does the AI productivity gain justify the infrastructure cost? That is the real business conflict. Not AI versus electricity, not old economy versus new economy. The conflict is simpler. When the bottleneck shifts, bargaining power shifts. And when bargaining power shifts, value moves. Let me make this concrete. Imagine two data center sites. Site A is cheaper. It is larger. It looks better in a press release. The land cost is lower and the project sounds impressive. But there is one problem. It has no clear path to grid connection, no secured interconnection, no reliable equipment timeline, no obvious answer for how the site gets enough power on schedule. Now look at Site B. Site B is more expensive. It is smaller. It may not sound as exciting, but it has a credible path to power. It has better grid access. It has a more realistic interconnection timeline. It has a stronger chance of becoming operating compute. In the first AI cycle, many people might have preferred Site A. Bigger land, bigger headline, bigger ambition. But in the next cycle, the market may start paying a premium for Site B. Not because it is more glamorous, because it is more usable. That is the value shift. When power access becomes scarce, boring assets can become strategic assets. A transformer slot can matter. A substation expansion can matter. A utility agreement can matter. A site with power can beat a site with hype. This is why AI infrastructure begins to look less like a pure software story and more like an energy, equipment, land, and regulatory story. Again, that does not mean software stops mattering. It means the bottleneck is expanding. And when the bottleneck expands, the map of value expands with it. Now, there is an important counter-argument, and it matters. This is not an AI-only bottleneck. AI is entering a grid supply chain that was already under pressure. Electric vehicles add demand. Industrial electrification adds demand. Manufacturing reshoring adds demand. Renewable energy requires transmission and grid equipment. Old grids need upgrades and replacement. So it would be wrong to say AI alone caused the power bottleneck. It would also be wrong to say every AI data center will be delayed. Some projects will secure power well. Some regions will adapt quickly. Some companies will plan better than others. Some utilities will handle large load growth better than others. This is not a panic story, but efficiency does not eliminate the business question. Even if AI models become more efficient, total demand can still grow. Even if chips improve, the physical system still has to support the load. Even if companies spend aggressively, infrastructure still takes time. And if demand grows faster than physical infrastructure can adapt, the bottleneck still matters. The point is not fear. The point is timing, cost, control, who can get power, who can get it on schedule, who can get it at a cost that still supports the business model, who can connect capital spending to operating capacity. That is the question builders, customers, investors, and policymakers should be watching. And I want your view on this. Is the real bottleneck now power access, chip supply, or demand not justifying the build-out? Hold that answer. We will come back to it at the end. Now let's make this practical. What should you actually watch over the next 6 to 18 months? Do not only watch model demos, watch the power signals, but instead of memorizing 9 separate indicators, group them into 3 buckets. First, power contract signals. Second, physical bottleneck signals. Third, permission and location signals. Let's start with power contract signals. The first thing to watch is power purchase agreements. If major AI projects keep signing long-term power deals, that tells you electricity is no longer just a utility bill. It is becoming part of AI strategy. The second signal is large load tariffs and grid rules. When regulators change how large power users pay for upgrades, the economics of AI infrastructure change. If data centers have to pay more for grid improvements, backup systems, or transmission upgrades, those costs do not disappear. They move through the system. The third signal is cloud pricing. If infrastructure costs keep rising, that pressure may eventually show up in customer pricing, contract terms, availability, or usage limits. Maybe not immediately, but over time, the cost of physical infrastructure has to be recovered somewhere. That is the first bucket: power contracts, large load rules, cloud pricing. These tell you whether power is becoming a financial strategy, not just an operating expense. The second bucket is physical bottleneck signals. Start with utility interconnection queues. The queue is where ambition meets the physical system. If wait times rise, planned capacity takes longer to become operating capacity. Then watch substation expansion announcements. Substations are not flashy, they do not look like AI, they do not produce viral demos, but they help decide whether a site becomes real. Then watch transformer, cable, and switchgear delivery windows. When delivery times stretch, the bottleneck is no longer theoretical, it is operational. A data center can have chips and customers, but if critical electrical equipment is delayed, the capacity is not fully usable. And finally, watch data center delays tied specifically to power access. Not every delay matters. Construction delays happen, financing delays happen, customer delays happen, but repeated delays linked to grid connection, electrical equipment, substations, or local approval. That is a signal. That tells you the physical layer is shaping the AI timeline. So the second bucket is simple: interconnection queues, substation expansions, transformer and switchgear delivery, power-linked delays. Those signals tell you whether the physical system is keeping up with the AI spending cycle. The third bucket is permission and location signals. Watch local resistance to large load projects. Communities may ask hard questions. Who pays for grid upgrades? Will electricity bills rise? Will local reliability be affected? How much land is used? How much water or backup power is required? Those questions can change timelines. Then watch site selection. If AI infrastructure starts moving toward power-ready locations, that means the market is adapting. The best site may not be the cheapest site, it may be the site that can connect fastest, the site with the clearest power path, the site where local rules, grid readiness, and infrastructure timelines all line up. And watch regional grid readiness. Some regions may attract more AI infrastructure because they can provide power faster. Other regions may have land and political ambition, but not enough grid capacity to turn that ambition into operating compute. That is the third bucket: local resistance, power-ready site selection, regional grid readiness. These signals tell you whether permission and location are becoming strategic advantages. Put the three buckets together, and you get a much better map of the AI economy. Power contract signals tell you where the money pressure is moving. Physical bottleneck signals tell you where the timeline pressure is moving. Permission and location signals tell you where control is moving. Those may not be as exciting as model demos, but they may tell you where the value is moving before the headline catches up. Now let's bring it back to the core idea. AI data centers are not literally becoming power companies, but they are starting to behave like large power buyers. And that change matters because the AI build-out is no longer just about announcing capacity. It is about converting money, chips, land, equipment, electricity, and permission into usable compute. And usable compute is where the business value begins. A data center without power access is not AI capacity. It is a promise waiting for the physical system. A chip order is not operating compute. It is hardware waiting for a powered site. A construction announcement is not a business model. It is capital waiting to be converted. That is the value shift. When electricity becomes the gatekeeper between AI ambition and usable compute, the players closest to power access gain leverage. So the next time you see a headline about another massive AI data center, do not only ask how big it is, ask a better question. Can it get power? Can it connect? Can it operate? Can it recover the cost? And who controls the bottleneck between the announcement and the capacity? Because the next phase of AI may not be decided only by who builds the best model. It may be shaped by who can turn ambition into operating infrastructure. That means power access matters, grid rules matter, equipment timelines matter, local permission matters, and power-ready locations matter. The headline will still talk about chips, it will still talk about models, it will still talk about billion-dollar announcements, but underneath the headline, the harder question is simple: what actually becomes usable compute? If you want to follow the AI economy beyond the headline, hit subscribe. We do not chase the announcement, we watch the bottleneck. And one question for the comments: which AI bottleneck matters more now? Chips, power, or demand? I am looking for the business reason behind your answer, not a stock call, because the headline is temporary, the value shift is not. See you in the next one.